this, we're just going to go over a factoring question here. So we've just been given a question. To make it an equation, we'll set an equal sign to the left of it. And the question wants us to factor. So there's quite a few different things we could do here. It says to factor or factorize as much as possible. One of the things we can do here. Oh, okay. So what's interesting about this question here is it happens to only have two terms. And terms are separated by either usually an addition sign or a subtraction sign. And you essentially get two terms. These are multiplied by variables, like you have a coefficient times a variable and a coefficient times a variable. We consider that one term. Even though it looks like there's a number and a variable and a number and a variable, that might seem like it's more than two terms, but we really just use addition and subtraction signs for separating terms in an equation. So with that being said, this one happens to have two terms, and one of the things about that is there is a really special style of factoring that works really well when you have two terms separated or subtracted by each other. It's known as a difference of squares. And it does take a little bit to recognize the difference of squares. But a difference of squares is essentially when you have, I'm going to set it out on the right here. We have a squared. So a just represents any number. Subtract, we have b squared. Okay. And when we have a scenario like this, the difference of squares is we're looking for the square roots, and we're usually looking for perfect squares. In other words, the square becomes what they call a natural number, which is just like a whole number. We're not really looking for squares that have like irrational decimals that go on forever. So in this case, a squared, a fast way of factoring this, when you realize you have this scenario, you can set up two brackets. And what's neat about it is you can put as the first term in each bracket, the first term in the equation, a, right? And essentially a is, if you take it to the side, the square root of a squared. So I say, what is the square root of a squared? Well, it happens to be a. So I put a as the first term in each bracket. And then same concept with b. What's the square root of b squared? Well, it happens to be b. I know that's very arbitrary, but we'll use some solid numbers after that. You can put the b as the second term in each. And then really nicely, we just have to make sure we have at least one of them have an addition sign and one of them have a subtraction sign. And that would be considered the factored form. So to get back to our numbers, we can run them through a test. The first term here is, we'll call this a in this case, 36x squared. So I'm going to take it to the top right corner, 36x squared. If it's a little too confusing, the square root, coefficient, and a variable, I can actually separate them. I can say, hey, what's the square root of 36? And what's the square root of x squared? And then just put them back together after. So the square root of 36, that actually happens to be a whole number, 6. And technically it's plus or minus 6, but we'll talk about it. For the factoring purposes, we're just going to go with the positive value here. And that's because the first term in this is actually a positive, so that's part of the reason for it. And then the square root of x squared happens to just be x. So the first term that we're going to set in each of the two brackets that we've set up at the end here is actually just going to be 6x and 6x. The second term here, which we can call b, is 81y squared. Same concept. In this one, I'm going to try to square root them both together, okay? So we did an example where we square rooted them separately. Here, we'll find the square root of the number, and it just so happens the square root of 81 turns out very nicely, to be the number 9, okay? And the square root of y happens to be, the square root of y squared happens to be y. So the second term in both brackets will be 9y. And then, like I said before, we just have to make sure one of them has an addition sign and one has a subtraction. And it doesn't matter which is which because of an associative property. It doesn't matter the order of multiplication. But this is how you would factor that number. A thing you could do after, just to double check, is you can then see if there is a greatest common factor in any of these brackets. And actually, there happens to be a greatest common factor. I can factor this even farther if I liked. Because there's a 6 and a 9 in each of the brackets, I can pull, and one way to do this is to break something into prime factors, but I'm going to go on the assumption you have relatively good skills with your multiplication tables here. So I'll quickly do it, and then I'll show you on the side, a sure way to do it. If you notice, 6 and 9, well, I can divide each of those by the value of 3. So I can greatest common factor the value of 3 out, and then I end up with 2x minus 3y. And then the same thing with the other bracket, I can take 3 out, and I end up with 2x plus 3y. Now, the one thing we do have to do after that is we have to make sure we just kind of collect this term at the end. And because there are two sets of 3, the idea is that you can take out the 3 times 3 would be 9. So those two 3's go together, and then we have 9 as the greatest common factor, and then 2x minus 3y, and 2x plus 3y. And if you're just unsure for the greatest common factor, a really easy way to get them all is you do prime factors of a value. So for instance, 6 turns into 2 and 3, 9 happens to be 3 and 3, and right there we have a common factor of 3, so I know I can divide both of those by the value of 3 in this case. Technically, and not to go too long into this because I already talked a bit about it, another thing we could do is I could have actually common factored first. So I'm going to shrink this just a little. And I'm going to very quickly, let's say I recognize that 9 was actually a greatest common factor right off the bat. So I'm going right back to the beginning of this question. I'm going to kind of speed through this a little because we've gone over the main things. But 9 actually comes out of both of those values. So I could say 9 was my greatest common factor. 9 divided by 36 is going to give us 4. So we have 4x squared. 9 divided by 81 gives us 9. So we have 9y squared. So I already have my greatest common factor out. And this is still technically a difference of squares. I can square root 4x squared and 9y squared. And when I do that, I get two sets of brackets. The square root of 4x squared is actually just 2x, so that becomes the first number in each bracket. The square root of 9y squared is actually 3y, so I put that as the second number in each bracket, and I just got to make sure I have a plus and a minus, and I technically ended up at the exact same answer, but I took two different roots to get there.